Okay, so this trig equation is the last one. Okay, I'm gonna do that complex trig equation. Alright, so the question is on the general solution. Okay, so the question says determine the general solution of 4 cos squared minus x minus sine 2x minus 180 degrees is equal to tan squared 675 degrees. Alright, the question looks scary, but it just requires application of what you know so far. Okay, so now 4 cos squared of minus x, you can write that first. Let me write the equation as it is given. So it's 4 cos squared minus x, okay, minus sine 2x minus 180 degrees is equal to tan squared 675 degrees. All right, now by now, all of you must be aware that this 4 cos squared of minus x is the same as 4 cos minus x all squared, like that, right? Minus sine 2x minus 180 degrees is equal to, now 675, we can subtract 360 from it. Okay, if you subtract 360, you get 315. So I can write this, okay, as tan 315 degrees all squared. Okay, because 675 is more than 360, so I want to reduce it to an angle which is between 0 and 360 degrees. Okay, so I subtracted 360 from 675 to get 315. I still need to further use my knowledge of reduction formula to get off. Now cos minus x, we know that it's equal to cos x, so this is the same as 4 cos squared x. Then I'm going to expand here using the compound angle. So that will be minus, open square bracket, sine 2x cos 180 degrees minus sine 180 degrees cos 2x. Then close the bracket. Now tan 315 can be written as tan 360 minus 45 degrees, which is the same as saying this is tan squared 45 degrees. Okay, and tan 45 is the 1. So if I simplify this, I'll get 4 cos squared x. But now, fortunately, this sine 180 degrees is equal to 0. Okay, so I'll be left with sine 2x cos 180, and cos 180 is the same as minus 1. So I can write this as minus, okay, sine 2x times minus 1 is equal to 1. Okay, this, you know, some of you are, I just hope that you did not make yourself rusty by not opening a book during the past. I hope you didn't do that. Because I thought that it's very risky for you to have spent over a week without opening a book. Because it means you are starting from 0. So this becomes 4 cos squared x. Now this will give me positive sine 2x is equal to 1. And I can simplify this as 4 cos squared x plus 2 sine x cos x using the double angle for sines. Okay? Then when I get here, because I don't have 0 on the right hand side, I have to take that 1 to the left, and then I'll end up having 4 cos squared x plus 2 sine x cos x minus 1 equal to 0. Now I need to factorize this. Okay? Now this question here is a higher order question. Right? I just want you to be aware of the following. If you want to factorize this, okay, I don't know how you taught how to factorize, but some of you I taught you in grade 10. I hope you remember this method, whereby you look at the coefficient of the first term and the constant term. Okay? Alright? Now, the other thing as well that I also want you to be aware of, for this question, we may need to convert this 1 to sine squared x plus cos squared x. So allow me to do that before I carry on. Alright? Then I'll do the factorization. So this becomes 4 cos squared x plus 2 sine x cos x minus open bracket sine squared x plus cos squared x. This will be equal to 0. If I remove the bracket, this cos squared x, it will be negative, so I have to subtract 1 from it. So I'll end up having 3 cos squared x plus 2 sine x cos x minus sine squared x, and that's equal to 0. Okay, now I can factorize. Okay, no, this can be factorized. Don't be surprised, it can be factorized. Alright, if you want to factorize it, this is how you do it. Right? You have to know your factorizing very well to carry on. Since we have got this product of sine and cos, right, let's concentrate on the coefficient of the first term and the coefficient of the last term. What's the coefficient here? It's 3. 3 times, what's the coefficient here? Negative 1. So you get minus 3. Right? Which two factors of minus 3 are such that if you add them, they give you a positive 2? Plus 3 and what? And minus 1, 32. So what that means is I can rewrite this 2 sine x cos x using the two factors of minus 3. I hope you have seen that method before. Right? So I'm going to split this 2 sine x cos x and I'll write as 3 sine cos x minus sine x cos x. Okay, that's what I'll do on the next page. No. You can catch up with the new stuff about. Right. So let me move on to the next page. Now, on the next page, I'm going to start by saying 3 to be 3 cos squared x, right? That will be plus 3 sine x cos x minus sine x cos x. And then here I'm going to put my minus sine squared x, and that's equal to 0. Then I'm going to factorize by grouping. Okay? So the first two terms, they have a common factor, and that common factor is going to be 3 cos x. Open bracket, that will be cos x plus sine x. Now once I create this binomial factor, which is cos x plus sine x, I also have to create it here. So that will be minus sine x, open bracket, cos x plus sine x. And that's equal to 0. Okay? Then factorize here, I'll get 3 cos x minus sine x times cos x plus sine x equal to 0. And this will give me 3 cos x minus sine x equal to 0, or cos x plus sine x equal to 0. Now, before I get on here, I just want to take you back to the original question. The original question has a restriction, okay, or a condition. Let me just go back for the one. The condition is that tan x must be greater than 0. Okay? That's very important because we have two equations here, right? We have two equations here. And both of them are going to have tan. So this one here I write as 3 cos x equal to sine x. The second one I'll write as cos x equal to minus sine x. Then if I want to create tan for both equations, I have to divide both sides by cos. So this becomes 3 cos x over cos x is equal to sine x over cos x. And the other one becomes cos x over cos x is equal to minus sine x over cos x. Now, the one to my left will give me 3 equal to tan x, which is fine because here tan x is greater than 0. The second one will give me 1 equal to minus tan x, which means minus 1 is equal to tan x, which means I'm going to reject this one here because tan x is negative. So I'll be left with one trig equation, which will be tan x equal to 3. Okay? Just want to remind you that this condition here, we have to take it into account. It's a restriction that tan x must be positive. Therefore, among these two equations, we have to reject the one which has got tan that's negative. Okay? So we are left with one equation. Then we use our knowledge of the general solution from here. So on the next page, now this one here, maybe we have probably around 7, maybe 8. You have lots of notes. But it will definitely have more than at least 5 marks. Alright, let me carry on. So once we get to the last point, the way for 3 equal to tan x, I hope you all appreciate that this is the same as tan x equal to 3. Right, then we introduce the general solution. To allow me to do that, you can catch up later. So this means tan x is equal to 3, therefore x is going to be equal to shift tan of 3 plus k times 180, where k is an integer. What is shift tan of 3? 2 decimal places, 57. Right, plus k times 180 degrees, where k is an integer. So that will be your general solution. Okay. So that's it. Okay. So this will be the end of my teaching on trig equations. Okay.